going on, team? This is Alejandro with the project for my third and I would say final assignment for the intro portion of the Gauntlet program. As you might know, or maybe you don't, but basically the first 3 weeks of the program are completely remote. They are meant to sort of like introduce you into the world of AI, software development, and provide you with best principles, best practices around leveraging AI for building AI. Basically, so far the program has been incredible. The instructors are great. The content and the material are, top of the line. And I remember being very anxious about those first 3 weeks because there is this sort of expectation to perform during those 3 weeks in order to be common to the rest of the program, right? So there's always that looming anxiety around what if I don't deliver the assignments or the challenges in time? What if I'm not able to perform? What if I can't do it? But here we are, 3 weeks after we were able to pull it off, and I think we are going to be working closer with Gauntlet's partners after these 3 weeks on like actual real life scenarios and real life challenges and requirements, and I'm looking forward to that as well. But as of right now, we made it happen. So I'm going to be walking you through LazyLens, which is the third and final assignment / challenge for the last of the intro portion of the program. So basically, it's a RAG system. Right? RAG stands for Retrieval, Augmented Generation. It's basically a design pattern using AI applications where a language model answers questions using external data retrieved at runtime instead of relying only on what it learned during training. So rather than relying on the model, it's actually tapping onto specific files or scripts or actual an actual part of the code base that it can retrieve information from, right? So in this specific scenario, we are tasked with building a RAG system for interpreting and analyzing legacy code. And the goal is to make COBOL and Fortran, which are very, very old and outdated code bases, queryable in plain English, so that we can ask questions like, how does this specific module work within this code base? Or what does this paragraph do? And get answers grounded in real source with specific citations instead of digging through, millions of lines of, this specific code by hand, right? So for the MVP requirements, we had to build a simple RAG able to ingest at least one legacy code base, redecide the code with COBOL, chunk the code, meaning breaking it into little pieces and generating embeddings for all chunks. Those are like little summaries, right, of the chunks. And storing the embeddings in a vector database and implementing semantic search across the code base. Finally, the objective was to build some sort of UI or CLI that a user could interact with for asking questions about the specific code base. So here is LazyLens. This is my approach to LazyLens. And as you can see here, the code base, I decided to go all out and integrate RAGs for every single code base requested. And each one of these code bases, as you can imagine, has its own formatting, its own structure, its own architecture. The objective of this tool is to make this queryable and to be able to ask specific analysis questions about the code, right? And what's interesting about this tool is that we have all these different analysis features in here that correspond to specific questions about each one of these code bases. And we have this seeded question that also correspond to each one of the databases. So if I wanted to ask a question about pattern detection for GnuCOBOL, let's say what code patterns to print across programs is going to come in here, it's going to access the RAG that we built, and it's going to give us a natural language conversational answer. In order to build this, while this is loading, we had to use, the amount of external services that we had to use for the chunking, for the vectoring, for the actual RAG integration. It's all over the place. For the deployment, we use Vercel, and for the backend hosting, we use Render. We built a custom class API that acts as a sort of, I don't know how to explain it. It takes requests and it answers questions, right? So we're running into an issue here, but that might have to do with a specific question that reacts. So we can always go back and try a different question. But as of right now, this has been working for every other RAG combination that we've tried. But yeah, this is LazyLens. Oh, here we go. We actually got a response. The retrieve contest shows several repeating code patterns in COBOL programs. Use external functions, error handling with display and go back. You name it. We have a high accuracy, 9.5 seconds of latency. We need to bring that down, but right now, everything is looking great. I'm going to try one more question, code explanation, and let's do what does GnuCOBOL specific command from BLAS. And like I mentioned, what our agent is going to do is going to tap onto the RAG that was built for that specific code base, and it's going to provide us with a very, very interesting breakdown answer of what that specific command does. Decopy. Decopy is a subroutine that's part of BLAS, basically in a multiverse of programs. Library is specifically designed to copy a vector of double precision numbers from one array to another. There you go. So thank you so much for your time. Really appreciate it. I'm doing this because I think that it really explains the work that you do in order to feel like you really understand it. So, but that's it for this. Thank you so much for your time, and see you in the next one.